Lesson 4.1 is some general information about functions. And we have studied many types of functions: linear, quadratics, cubics, quartics, and so on. And our general definition of a function is that it is a mapping that will assign to every element in a set D exactly one element in a set R. For each x, there would be exactly one y, as we typically talk about x and y with the variables. But it doesn't have to be that. It could be a and b, e and f, and so on. Set D is called the domain of the function. So in the function that I have here, that is mapping x to f of x, the domain would be 2, 3, and 4. Set R is called the range. That is what each element in the domain is mapped to, and the range here would be 5, 6, and 7. You can see that each element of the domain has exactly one output. If I would add a point and also map the 2 to the 6, now this would no longer be a function because the input of 2 has two different outputs, or two different elements of the range. Typically we talk about y being f of x, meaning that y is a function of x, and that the y will depend on the x. So x is typically called the independent variable, and y is the dependent variable. We typically use y, f, and x, f standing for function, but you can use others, just like v equals g of u would be the function g mapping u to v. So if the domain of a function is not specified, it is understood to consist of those real numbers which the function produces real values. So if you think about this, what is not a real value? Things we've talked about already is that you cannot divide by 0. So anything that would make it undefined or make the denominator of a fraction 0 could not be part of your domain. And the square root of a negative number obviously involves I and is not a real number. Everything else we've talked about produces real numbers. So when you're talking about given a function and stating the domain, if it doesn't have a fraction or if it doesn't have a square root, your domain would simply be all reals. So for example, in these particular functions, this first one, 2x plus 5, is linear. Again, it doesn't involve a fraction or a square root, so that would be all reals. The second one here is a parabola, that would be all reals. Skipping down to L of x, this would be all reals. All right, now when we get to one like h of x, that is a fraction, we know that this denominator, x minus 2, cannot equal 0. X minus 2 cannot equal 0. What makes that equal 0? When x is 2. So we would say in this case, the domain would be x cannot equal a positive 2. It would be all real numbers, all reals, except 2. Everything else would produce a real value. In k of x here, we have a square root. So we understand that to be able to do this, or to get a real value, the 2x minus 1, that part that's under the square root sign, must be greater than or equal to 0. Because if it's negative, it would produce a non-real number. Now if we solve this, we would add 1 and divide by 2. We would get x to be greater than or equal to 1/2. So this would be the domain of that function. Would be values of x, where x is greater than or equal to 1/2. And you can see the difference here in h of x. We're saying what x can't be. It can be anything but that. And in k of x, we're telling you, or we're saying what x can be. Q of x down here is a combination of the two. We have a square root on the top, so we know that the x minus 3 part has to be greater than or equal to 0, which means x has to be greater than or equal to a positive 3. And then we also know that x cannot be 5. So in this case, the domain would be everything greater than or equal to 3, not equaling 5. So in summary there, if you have any type of function that doesn't involve a fraction or doesn't involve a square root, your domain is all reals. If it does involve a fraction, the bottom cannot equal 0. If it involves a square root, whatever's under that square root sign has to be greater than or equal to 0. So dealing with the graph of a function, the domain of y equals f of x is the set of the x coordinates, any potential x coordinate, and the range is the set of y coordinates. The zeros of the function would be the x-intercepts. And then a very important test is the vertical line test, which says if no vertical line intersects the graph in more than one point, then the graph is a function. So for example, in this first function, you can see that if I drew a vertical line right here, I would cross at more than one point. So this would not be a function. This next one, yes, it is a function. It would pass the vertical line test. So for domain, which is the set of x coordinates, you can see that the entire graph is from here, this is on the x-axis, to the right. So we would say the domain would be x is greater than, and since it's a closed dot, greater than or equal to 2. The range is then on the y coordinates. And you can see that the graph is from here on the y-axis and then extends up. So the range would be when y is greater than or equal to, again, because the closed dot, 1. Because that point right there is the point 2, 1. As far as the zeros of that function, there would not be any zeros because there's no x-intercepts. Looking at the next one, does this pass the vertical line test? Yes, it does. There's no 2 points that line up vertically. Domain. On the x-axis, you can see that the graph is between -3 and 4. And it's closed dots, so we would include those two. And then for our range, you can see the graph is between -2 and its highest point would be +1. And those are closed dots. So that would be the range of that function. The zeros here, you can see the zeros would be -2 and +2. This next graph, a little bit broken, so it's not a continuous graph. It's still a function because it does pass the vertical line test. And then our domain, you can see that on the x-axis, everything is from here to the left. It starts again here and goes to the right. So we would say the domain would be anything less than or equal to -1. And then greater than 2. Just greater than because of the open dot when x is 2 there. Range. Looking on the y-axis, you can see it's from positive 2 and then it goes lower. So we could say y is less than or equal to 2. And then it jumps up. It's discontinuous till we get to 3. And then it goes higher. So we'd say y is greater than 3. The next example here, you can see this miserably fails the vertical line test. This would not be a function. This next one is a function. And then looking at domain, on the x-axis, the graph is from here and then continuously all the way to the right. So we would say the domain is that x has to be greater than or equal to a negative 4. And then the range, you can see that the entire graph is going to be between 0 and a positive 2 on the y-axis. So it's a tweener between 0 and 2. We got closed dots, so we'd have equal to. This one has a 0 of negative 1. So I hope this helps in completing the 4.1 assignment on Google Classroom.